Alright, okay. Time to get started with our guest. Now, our guest today is Andrew Miller. Andrew's title is something like Innovation Manager from Thiess Constructions. Now, Thiess do, I think I'm right in saying, more big stuff, civil engineering sort of stuff, rather than sort of straight building work as such, but it's all applicable. And he's going to talk to you about, well, you can see there, he's going to talk about building information modelling largely. So I'm not going to say anything else, I'm going to let him go.
Right.
They're all yours.
Thanks, Rick. It's good to come down here again today. This must be the third or fourth year?
Easily probably the fourth time you've spoken to us, actually, once remotely.
Yeah. And I was trying to remember what time of year was it last year when I came down?
Probably the middle of the year.
Right. Yeah, so just to give myself a bit of an introduction, I am the Innovation Manager for Thiess, have been for about 10 months now, and it's interesting how I got to be the Innovation Manager, because one of the main innovation, if you like, that actually inspired me to think about innovation in a wider context was BIM, and I actually wanted to put in brackets there model-based construction, because it's a term that we're using more generally lately. BIM is something that's right out there now as an acronym in the industry, building information modelling, but because we need to apply it, as Rick said, often in major civil construction and certainly places outside of building projects, we do look for another term. So we have been using the term model-based construction, and you'll see that come up as part of the presentation as we go. So just as a bit of an outline, and contrary to previous years, Rick, I was actually going to set BIM in the wider context of innovation today, given that's sort of where my role's gone to, but I'm certainly framing it up as the most important one that we have to consider in the industry at the moment. But I also want to talk about the term innovation, because it's an interesting term that you can use it as a noun or a verb. A lot of people look at an iPad or something, which is certainly an innovation, but they sort of come and go. I think the one we need to talk about is certainly the verb, where it's an evolving and ongoing process of innovation and renewal. So we'll come to some definitions for that. But even before we get into the nitty-gritty, I wanted to set that term innovation in the context of Thiess, which is our company, and talk about how Thiess has evolved. We'll certainly get down to the latest project, BIM case study type stuff, Rick, but I think it's helpful if people can consider BIM in this light, because then they see it as fitting with part of the wider business setting. So just to go through the step by step there, so yeah, we're going to go back to the 1930s and talk about innovation, and then set that as part of the business framework. And then in answer to the question, where's the best bang for innovation buck, where I sort of already answered it, and we're talking about BIM more and more right across the business. So the BIM and model-based workflow case study activities will then come through with the recent activity that we've been up to. And plenty of questions and discussion at the end, fine. So I think I might have thrown this one up last time. I've since worked it a little bit more, but I think it's a pretty good icon for the current position that we see ourselves in the world, where we used to build things quite manually, with hand tools and no machines at all. Then along came the 1900s, where we used machines, and the machines got bigger and better, and efficiencies increased through mechanical means. But now we're very much into the information era. I think the recent IBM report that they got Ibis World to do actually uses the term infotronics age, which is fine, but information era, I think, or information age is a good way to think about it. So, and that progression there, where you see it going from just the sense of an evolution, and then eventually everybody sitting at a computer. I talk to guys who used to, even guys not much older than myself, 5-10 years older than myself, and they're quite amazed to walk into an office now and see everybody sitting in a computer, because it just didn't used to be like that when they first started. So it's this 20-year period where we've all come to be sitting in front of computers as the first port of call. But as I said, these machines are the ones that we started with. So Thiess's history started in the late 1920s, early 1930s, where there was 5 brothers from the Thiess family bought this tractor, which they still have a lot of their old machinery. This shed here actually belongs to the Thiess family at Sunnybank in Brisbane there. and they've still got a lot of the old machinery that they've done up and kept in good working order, which is quite interesting. So I went out there and took some photos, and you can see the black and white picture of it from quite a while ago there as well. So that's just to frame up where we started in the 1930s, and then the 40s and 50s. The Thiess brothers had to innovate. Everybody always has to innovate, but they don't actually like to admit to it a lot, particularly in the current day. But as you look through history, you have to innovate to keep your efficiency increasing. So as they started to build more things, airstrips and roads and eventually buildings, dams were quite big. They were always with the latest technology, and to the point where they bought a plane. During the war years, they did all sorts of stuff where they had to get up at early hours in the morning and make phone calls just to connect with each other, because the phone lines were taken away during the war and that sort of thing. And the picture of the Jeep in the jungle there is in Papua New Guinea, where when they couldn't get the machines they needed to build the jobs, they literally went to Papua New Guinea and pulled the wrecks out of the jungle that the American army left behind, brought them back to Australia and fixed them. So that was them innovating with what they had to work with back in the 1940s and 50s. And just the drawing here I think is interesting, because that was their first major contract in Australia. In 1958 I think it was awarded a big tunnel down there at the Snowy Water scheme, and they were the first contractor to get awarded, the first Australian contractor to get awarded a big contract. I think it was $58 million or something, and they had to dig this huge tunnel. So the next photo actually pops up, I think, is a photo from the site where this cross is, and it's you can see on the profile of the land, it's the lowest point, so they needed to use that to access the tunnel for ventilation, and also getting machinery and everything in there. So I think there's an interesting passage. Again, I know you've got the architecture and building focus here, but it helps people, I think, if you can think about engineering projects as being more general. Certainly one thing the computers does for us is actually enable us to think like that. So I'm going to read a short passage which just describes the scene at that site when they first started. Jacobs, who's a guy they brought out from America, was a real guru with tunnels, suggested that a small bridge be built, and the site located on the far side of the creek where there would be enough room for a workshop, offices and parking space for the underground equipment to be used. He then flew back to Sydney to design the equipment, and Stan got things moving at Deep Creek. I didn't have any surveying instruments, he said. I didn't have any surveying instruments, he said, so I eyeballed the area and set a couple of D8s going on the site. An astonished Snowy Water Mountain Authority engineer appeared a few days later and asked, "Where are the drawings for what you're doing at the portal?" It was news to Stan that he had to supply drawings to get approval before starting work. He kept the men going, supplied the drawings later, and the Snowy Mountain Authority engineer winked at this initial piece of unorthodoxy and kept officialdom happy by giving written permission to level the site sometime after it was completed. So I think that's fascinating, because those guys back then were doing what we're doing now with these computers, because technology's come in such a rush. And in many places the computer tools actually aren't classed as proper engineering tools, but obviously they are. And it's indicative of the generational gap at the moment. So we're having to go out on the projects, the guys that know about the computer systems know we need to use them, and literally without any protocols or anything to do with how we're going to deliver that package of work using the computer tools, we've just got to get in there and do it. So it's interesting, I think, because we sort of come full circle in that sense. So 60s and 90s, as I say, it was all about machines. This one's actually probably more recent. That's probably one of our latest photos from the 2000s with the big 996 there and a large mining truck. But this one, in the 2000s and 2010s, I've got a picture of an iPad, but I don't mean it to be an iPad, it's just a computer. And I've shown it overlaid there. And you might have seen the progression as we go with that red line on the timeline as well. So now we've got this extra layer where the computers overlay the machinery. And in order to innovate, in order to increase our efficiency, we need to get smarter with the computers, get better computer systems that control the machines, that control the delivery of the projects, your survey set out and all that sort of stuff. All the information comes through the computers. So one of the best descriptors for those sort of workflows is BIM, building information modelling. If you think of building in the sense of building anything, a lot of people would have liked to have chosen something different, but the way the software companies are sort of dictating in that space because they're the leaders, that's the term they chose. So we're talking about model-based construction to try and simplify it a little bit for the older generations. But I think this one also helps too. So to wind that timeline right back and talk about a framework for business, where the Thiess brothers started up, they had people and they had work, and they were the two most important things. Look after your people and get your work done. So they communicated with each other to deliver the work, and the work earned the money that facilitated their life. So now you go to 40s and 50s. Actually, pretty soon after they started and got to become a big company, it was obvious that they needed some business minds and some accountants and that sort of thing, because the guys didn't have any qualifications in engineering or anything. They were just really passionate about getting some good work done. So there was this phase, and it's all actually documented in this book here, which is why I know about it. We're one of the few companies I think that's had a good book written about their history, so I'm sort of just reiterating stuff out of there. But in any case, as I say, between the 40s and 90s, it was really about the machinery doing this work, and as long as you were keeping up with the latest trends there, you were successful. So your business relationships with your vendors and your suppliers and your people organising your money for your company became very important, but again, the money still facilitated their lives for the people. So now, I think you've got this other one in there, which is the 2000s, and particularly as we move forward now, computers are becoming infinitely influential with what we do. And that's pretty broad to say computers. And what that's done is actually plucked the technological element out of work, because there's still a lot of technology trends in here that we need to keep up with the machinery and survey equipment. But this one's the one we're struggling with the most at the moment, and we all need to work together to get it right. And the information is the thing that has to go into the computers, and then it has to be communicated out of the computers to get into the real world. And with people who learn a different way of doing that, currently in the positions of that are managing the company, it's really difficult to sort of join the worlds and explain everything properly, because there's never any time. When you're running a business, you've got to make money. So these sort of discussions are really useful, and these are the sort of presentations that I'm spruiking around the place, I guess, to try and raise our awareness about these things. So back to the innovation term and the noun versus verb, there's just some icons there again to stress the point that there are two forms of the word. Renewal is a very good word to try and think about innovation. You're constantly renewing what you're doing to stay ahead of your competition. Obviously, a positive change is an efficiency increasing change, and innovation really is just a bigger word for change, but it's a structured change. But in everyday terms, you could say we're just making the best of what's around, and combining things is another good word. So, I mean, you look around you with everything you do in your life, things get combined to remove an interface. That's increasing your efficiency with so many things that you do in the current world. I think that's a good way to think about innovation. But this little cartoon is also another one I often use, again, to make that point. And just at the end here is an interesting point where the human nature is to make a knee-jerk reaction about any suggested change. I've overlaid there just to tidy that up and make it fit with that now versus verb situation. But the little triangular mouse, or whatever it is at the end there, it's a typical knee-jerk reaction that I see, where he doesn't want to make the change because it's going to require, he perceives it to be requiring extra effort, when actually the end result is achieved much quicker by using what they're proposing. So the big bang for buck, BIM and model-based workflows. So we'll talk about that. Now these slides I've got here are actually run at a BIM in practice conference last week. Was sort of chaired by Building Smart. Are you familiar with John Mitchell?
When I was a cadet architect in 1974, John Mitchell worked in the same office I was in. So I've known him for nearly 40 years.
Is that right? Well, that's very good. I mean, he's a very passionate leader in the industry for BIM and model-based workflows, and he chaired the conference last week where my best and brightest engineer with BIM workflows came from Melbourne to present the slides that I've got here. And he started with this one, which I thought was interesting because he's saying, what's the end game? Why are we doing all this stuff? I mean, what's possible? I don't know whether you've seen these. I could certainly send through the links after today. But yeah, there's places in Asia where they're putting buildings up in a frighteningly short amount of time, and telling everybody about it without any reservation for, you know, keeping things close to their chest or anything. So I think this is a real big message for the Australian industry. We can do things a lot better, a lot quicker, and a lot of it's about modular prefabrication and this sort of thing. But BIM is an enabler for that. If you can get the information out of that computer, as I said, which is the BIM information, and then materialise it in a factory as a module that can then be taken aside on a truck, and the building goes up much quicker. You see these YouTube videos, and it's quite amazing, to be honest. And one of theirs over 12 months old now, where they put that 30-story hotel in China there in 15 days. They had the ground done, so they had the piles and the slab and everything on the bottom, and then it was just a steel frame. 2 modules came in on every truck, and you just watch the time lapse. It goes up in about 8 or 9 days, and then it sort of comes down. There's like a curtain comes down with the cladding and all the fit out and everything, because they had everything on every module had everything it needed. Tiles, it had a precast slab, it was steel. They had all the blinds, windows, doors, staircases, everything was there ready to go for that little part of the building. And yeah, it's quite amazing, to be honest. I mean, you know, necessity is the mother of invention. We don't need to be that good in Australia, but there's certainly little things in there that we can do better. And there's a lot of push-pull situations in the industry with governments and unions and contractors and designers and all this sort of thing. So if you can get a little bit of efficiency and iron out a couple of interfaces and make them, you know, work better together, we all do things more efficiently. So you read the articles in the paper these days, the government's saying that infrastructure costs 20 to 25% more than what it should right now because of all the discontinuity. So innovation is the way to go and to get things moving. And as I said, BIM's the main one we should be focusing on. Now this one's pretty startling, because it's saying, righto, of all the countries around the world, who's adopting BIM at what rate? And the blue one is us. So we're here. And I think this slide came from David Slangdon. So there's a lot of research being done and people writing papers and all sorts of things about why and, you know, what's happening and all that sort of thing. But it's charts like this which really bang it home. But then proactively thinking rather than doom and gloom. These sort of slides are also very useful to show people where in the delivery cycle of a project is BIM going to give us the benefit. Now, that's a big chunk, and it really is hard for people to think all the way through to 50 years after you've built a building. But the reality is we know that there is this infinite benefit that can get there. Not infinite, it is finite. But you've got to make the decisions early to get there. Because there's only that little bit of benefit right at the start there. If you change the way you're doing things, if you start working with these model-based workflows, you can access all this value later on in the project life cycle. Well, we're getting a bit mixed up right now between IP issues where people think that particular pieces of information are their IP and all that sort of thing. You know, it's easy for us in a sense because we don't hold any IP in information. We just, you know, our IP is how good our people are at getting it done. Whereas people before that, with your designers and your architects, the information is their output. So depending on how good they are at making that information, that's where their IP comes from. So it's interesting, I think, Rick, that you get me to come down here and talk as a contractor in many ways because, you know, I'm sure you're well aware of all these interplays and that sort of thing in the industry, but BIM is the great engager for everybody. It's everybody working on the same sort of platform and integrating from others that don't talk to each other, and everybody understanding their work much better as we do it.
And when I first started getting someone to come talk about this stuff, it was Paul Nunn.
Yeah.
Then working for Lango Rourke. Is he still with Thiess?
No, he's actually, and this is another symptom of the industry where Paul got offered a lot more money than what we're paying him because there's consultants in the industry working as BIM management consultants. Right. And it's got to only be a finite window because, you know, we need to manage our own information, and it's an unnecessary interface if you ask me. But because people are in this culture where they're happy to pay others to manage certain things and outsource certain things, you can start up a consultancy at the moment as a BIM manager.
Well, when I first met Paul, when he was with Lang O'Rourke, handling BIM stuff, I mean, you say it's interesting that I get you down here presenting what it's sort of a contractor's view, but what Paul was doing at Lang O'Rourke it was actually Lang O'Rourke who were driving the ship at that stage.
Yeah.
Therefore, I don't know, is that the same with Thiess? Are you exerting that sort of influence? Because Lang O'Rourke certainly were running the show and basically hiring other consultants, engineers, architects and so on, and telling them how they were going to do it.
Yeah.
To meet Lang O'Rourke's requirements for a BIM-based and model-based approach.
We're trying to get there, I know that. I mean, I've been at Thiess 8 or 9 years and I've been trying to get there. You could say that Paul coming and going is symptomatic of a few other things, but to think more positively about that situation, Lang O'Rourke is a company run by virtually one man, Ray O'Rourke, and he has a vision where construction projects, whatever they are just done as if you're a manufacturer, you know. So we know we need to get around to this manufacturing mentality, and with the recent change in our managing director's seat, there's good recognition about the mentality that Ray O'Rourke takes to construction. It's a long-term mentality, whereas, you know, typically construction projects, people approach them with a short-term mentality because you push them out in 2 or 3 years and then you go to the next one. But if your company approaches that as a series of projects rather than just one-off things, then you start to procedurize your approach to the world and put repeatable procedures in place as well. And that's, Lang O'Rourke are a very good example. They've interestingly had some organisational changes recently, and that was what forced Paul to leave Lang O'Rourke in the first place as well. And with the downturn in the UK, I know they've been flooded a bit down here with English people. We've actually taken on a few people lately from Lang O'Rourke, 3 or 4 that I can remember in the last 6-8 months. So, you know, it goes swings and roundabouts, and I think that you're really going to start to see a lot better progression with Thiess. We certainly lead it wherever we can, but when you take on a big job like Vic Diesel, which I think I presented when I was here last year, that job was actually too big for the industry. It was just a mega project, and we actually didn't have the capability.
This is the Victorian desalination plant.
Yeah, it was a highly technological project, and with all the inconsistencies in the Victorian industry and pretty much the worst set of, if you can think about it, if you're playing a game of cards, you've basically got the worst hand dealt to you for that project that you could get dealt. But, you know, we're hanging our heart on our sleeve with that one and saying that we finished it and it's now making fresh water. Handed it over, you know, basically. So yeah, we always get the job done. We lost a heap of money on it. But it's a good wake-up call for the industry to say these projects are becoming really technologically dependent. So we have to get better with the technology side of it. And yeah, we're trying to get there. I mean, guys like John Mitchell are very, very helpful. I was really pleased with that conference last week where he's now heading off to the federal government in Canberra to try and get some funding to push BIM and standardise BIM, which is exactly what we should be doing. So the contractor's perspective, as I said, is to get the work done. The screen on the left there, we are trying to change the way we construct, and typically in history, or in years gone by, when a job's been delivered, they would report progress via a time change diagram or putting actuals back into a construction project and program and printing out a Gantt chart. You know, these forms of communication are actually dying because you can do things with models. You can have all that intelligent information in the one place and then have other ways to get it out of the computer and show it to people. This one will get blown up in a couple of slides where you see people out on site with iPads. We're starting to use the models on site for toolbox meetings. I think I had some of those photos last year as well. So just sort of over the last 18 months, things have really started to ramp up in terms of relying on these models more than the 2D drawings. To actually materialise that in the real world. And there's another one. So now we're about reducing the complexity around BIM. BIM has been seen over the last, probably up until about 12 months ago, as something that was just, scaringly complex. But it's certainly not the case, and a lot of our internal work in terms of putting strategic plans and capability statements and that sort of thing in place for us to use with our clients is to show that it's not that complex and that we can actually leverage it to build things better. I think I showed this slide last time. I think it's very, very indicative of the fact that we've got a model, and maybe that wasn't the right slide, but I thought it was going to be. That's a shame. Normally, we might see it later, because as I said, these slides have actually come from my guy in Victoria that I'm presenting, but I do have a version of this slide where you see the model and you press the button and it just literally just fades into reality from that same perspective, because that's the model and we actually built exactly that. But this one's a recent one that we've done down in Melbourne there with the Regional Rail Project. The guys are actually getting models in their hands where they can simulate the vehicle movements, they can measure things, they can understand risks well ahead of time. So safety is a big thing. And safety is almost the ultimate thing in the industry, because it's a KPI that we really have to work to. And if you can have an information management system such as BIM that's going to help you reduce your safety and also your process risk, technological risk, then it's a very useful thing. As I said, we're challenging the way we construct. This is a view of a P6 program, a Gantt chart that has been the norm for quite some time. Probably 20 years. But we're saying that that's not what we're going to do anymore. We're going to use more streamlined forms of communication, communicating information in terms of graphical displays, and as long as we know that whatever we're exporting from a database or a model is correct, and the graphical information that we're presenting represents the time change information, then there's nothing wrong with doing that, because people understand it much quicker. Again, there's that one just blown up where you see a railway station that we're partway through building in Melbourne at the moment, and you've got a progress timeline there where they're showing what they've done. So the green is just the work that has been done as it progresses through time, and the date rolls around and the little white text on the top. So now this one should play, and you actually see the model that the guys used to do a package of work over Christmas. So this is the Regional Rail Project, and you've got a heap of machinery there. Every vehicle in this model, and this is just one perspective with all the activities rolling around there, you can actually move in there. Like, I mean, it's a full model. You can navigate yourself around and press pause and select things and get information out of it. But as a distributable piece of information, you save a video file. So this is a video from one perspective. We'll see a couple of other perspectives as images later on. But basically, it's one of the most horrendous situations to get some work done, because you've got live trains that need to keep going. So you guys have got to come in, do the work, get out again, as per the negotiated timetable with the rail authority. And the guys modelled everything in advance, and they know where every vehicle is going to be every hour that's involved. And the big win story for this package of work that we did over Christmas there in Victoria is that they actually encountered some unknowns throughout the delivery of it, which is what always happens, and that's where you lose your targets and your progress. So they found some ground conditions, and they lost about a day and a half. But every day then, they would sit there at a toolbox meeting and go step by step with everything they had to do because it had been modelled in advance. And throughout that 2-week shutdown, they actually made the day and a half back, which was a big win, because a day and a half with a complex project like this one is huge. So to have a mechanism that enabled them to make that time back, you know, it's really hard to put a return on the investment on it. People always, one of the inhibitors for BIM's always been people saying, you know, you need to tell me what the return on investment is. Well, it's almost past that now. We've got some numbers here which you'll see how many hours we did actually save by modelling it in advance. This one is another version where you can see what I was talking about with the model fading to the real situation. So, you know, you really can't argue with that the project was documented in the computer and modelled in the computer ahead of time, and we knew what we were going to do. Alright, so we go step by step here with just some shots from model review sessions. There's the guy that Rick was talking about with myself, Paul Nunn. So we worked together for about 18 months while he was at Thiess, and he's a real BIM evangelist, and he is an industry leader, even though he's working for a consultant. I think eventually that'll hopefully peter out, or we might be able to convince him to come back. Because yeah, he's certainly a very clever guy, and not too often that you find someone who's sort of in their late 50s who is really passionate about it. This one's an augmented reality drawing. I'm sure you guys have probably tinkered with augmented reality on your iPhones or whatever for travel apps and that sort of thing. And I mean, the term augmented just means sort of additional. You have an augmented vehicle, it's got 2 carriages. So augmented reality is adding extra information to reality. So if the extra information lives on the iPad, which it is here, you augment your reality by looking at your reality through the iPad. That's a toolbox meeting that we had at Vic D-Cell, and there's a toolbox meeting that we had down at Regional Rail for that package of work that we saw the model for. That's a senior guy on site with his iPad, and I think they actually had a race, those guys, to see who could get the information first, whether he could get it out of the iPad or the set of drawings first, and the iPad killed it. So there's another guy on site with a handheld. Everybody's connected. I mean, Wi-Fi's a fantastic thing. Even nowadays, you've got 4G coming along, which is quick. That little thing there I bought last year is the 4G wireless. You can have 15 people connect to it, and yeah, the speed's actually better than my cable at Western Suburbs in Brisbane. So the speed's coming, and a lot of people don't understand that the NBN, that's what it brings to us, is the connectedness. I think about that slide with the aeroplane where the Thiess brothers used to fly around, because that was their mechanism to connect. And that's what the NBN does for us. I mean, it's going to change so many things, but it's only, you know, we need to be gearing up for it. This is a work pack where a supervisor's dumping images out of the model to show his sequence of work and help communicate what needs to be done with his guys in the field. Again, here's another shot from that model from the railway project. And there's the little back analysis that we did as to how much time that model saved everybody. It's quite a lot. So there is a little bit of extra effort that needs to be applied to get it set up and that, but it's nothing compared to that, what you can save. So these are the big messages about BIM. As I say, reducing the complexity around BIM. It's really important with all the different disciplines in our company that everybody gets on board, because ultimately you can have a BIM be as intelligent or as simple as you like, and every BIM on a project needs to be tailored to the project. You're not going to go and do it for something that you don't need to. Ultimately, it can be viewed as a tool. And we have design managers, planners, estimators, document controllers, cost controllers, and procurement people without even mentioning the engineers, project managers, construction managers, these are just core disciplines of people that have a job to do and have a stake in the BIM. Because if your BIM is correct, corresponds with your 2D documentation, well, it's an easier place to get information from, because you can go in there, you can pick something and just, you know, right click, well, who's supplying this, like, what materials is it made out of, how long is it, isolate it, have a look at it, all ahead of time before you even get out into the field. And I don't think I have this slide today, but one of the ones I've had in recent years was a 3-step series of images, the last of which was a photo showing this pipe arrangement. Now, if you can picture a pipe, 3 pipes going into a wall, we had a situation on Thiess where the design was like that for the 3 pipes. So you've got different disciplines on the job. You've got your civil guys and your mechanical. Now that's the very interface between civil and mechanical disciplines. So what happens is the civil guys come along, build a wall, and they cast these penetrations into the wall. So the mechanical guys can come along later and join them up. So what happened was the civil guys got a wrong version of a drawing or something or other and cast these pipes vertically like that. So these weren't even there. It wasn't like that. But because we were doing a model review on it and keeping it up to date, we actually got the surveyor's set-out file and put it into the coordination model, sent it back to the designer. We didn't even pick it up ourselves. The designer was looking at the set-out file from our surveyor, and he said, can you just go out and check if those pipes are actually on the angle or if they're vertical? Because he was designing his pipes to come through and fit these. So we caught that one, and that was a big delay. It could have been a big delay on site. If you have a set of pipes turn up that have got elbows coming out here, and they're different pipes, you've got to order them again, or you've got to cut them, or you've got to think, worst case, depending on what the requirements are, you might have to actually cut that little wall out to get it right. And it's this rework, it's this avoiding rework that BIM can do for us, which really brings the value for everybody, to be honest, because nobody has to redo what they've already done or change what they already had planned in advance. And that was just a little side note, because as I said, everybody's got a different software package at the moment, whereas with BIM, it's a combining thing. We can take the work outputs from all those disciplines and put them into one information system and tailor ways for people to be able to retrieve them and communicate that information. So one of the big things is about using BIM, leveraging BIM to connect all the disciplines and get everybody on the same page. Here's a screenshot from Thiess. And this is a software package called Navisworks. It's got an add-in called iConstruct. It's probably our preferred system, but you know, you've got to be agile these days. There's a number of ways you can do these things. But basically, it's a software interface that lets the people view the model, allows them to pick that pipe, which it has there highlighted in blue. And by pressing that pre-configured button there, which everybody has access to, the relevant 2D drawings popped up. That one might actually be the P&ID, which is a piping instrumentation diagram. So it's like a schematic diagram, so the mechanical engineers can see the process of the pipes that they're building. The other one here is an isometric. So when you build pipes, you get what you call isometric drawings, which are sort of just like stick drawings that show how long this bit of pipe is, and then it meets a flange, and then it keeps going like that. Totally boring to architects, sorry. But you can think about pipes, you can think about walls, you can think about facades. The last building I worked on was 400 George Street in Brisbane, so that was 2007, and we had a very complicated facade on that one. We had some models for it, but they were the architect's models. We didn't get the engineering. There wasn't an engineering model done, so it was documented in 2D at that stage. So you can see how everybody needs to be working in it to get the full value. So at that stage in 2007, I actually reverse engineered the engineer's drawings as the contractor to get a model that was close to what we were going to build. And we did what we could at the time. We connected the construction program and one of the big wins was we sort of confirmed for the guys that they could go from an 8-day cycle to a 5-day cycle in terms of the floors. So it was a 36-storey building, I think, and there was 2 halves to it. So you had 8. Normally it'd probably take 8 days, but they wanted to go quicker, so they planned it and helped make their decision that they could go for a 5-day cycle for half the floor using the 4D model. And that was back in 2007. This is a good screenshot from a typical model review where I think there would be actually an architect's model overlaid with a designer's model there. And it's particularly good for that interface because you can take both of those models, put them together well before even the contractors come along. So during your design development, if you overlay your architectural model with the designer's model, engineering model, you pick things up that aren't consistent, the engineer's going to push back on things, and with conventional information workflows and 2D workflows, the turnaround is much longer because you'd see a marked up drawing and then somebody's going to lodge a request for information, put that into the doc control system, weeks later someone will respond to it. Whereas this way, if you're all just even live, we've done model reviews in a live situation with designers where we've said, no, you've got to move that, it can't be there. And they note it down, it's tracked as part of all these viewpoints. So the guys say this one, they've saved that viewpoint, they've circled it and said, put the comment in over there, what is that? So move east to avoid the trenches. So you note that there, you can say who's relevant for it, for the comment and what needs to be done, and it's all tracked. And then using that, I construct that in that I had there before, it's just a button you press at the end of the meeting, which is going to collate all that work into a PDF file, and then you lodge that onto the doc control system. Because then anybody can get it, see what happened in that meeting, go and do the work they have to do, check it off, and the world turns. So there's the PDF export from the Regional Rail project. It's just a template. It's just sucking that information, sticking it onto a PDF file, and making sure that we don't get that problem on site. We fix it before we get on site. Quantities, we're getting there in terms of people signing off on their model. When the legal factions of the world are sort of happy with the risk exposure and that sort of thing, the designers can start actually signing off on their models for the quantities, and we can order materials and all sorts of things directly from the model. So this is actually a quantity export from the model. It's just a spreadsheet. Spreadsheets everybody's trying to phase spreadsheets out. They're still very useful, but the world needs to get to a place where we don't actually rely on spreadsheets. In any case, that's a quantity export, so we'd call that a material takeoff. And there's an architectural drawing. So that's a model that an architect's rendered with a photo, or actually it looks like it might be a full model with photographic textures. Particularly with jobs in built up areas, government clients are quite demanding of nicely rendered representations of projects. It's interesting when you're working in mining and with mining consultants, they really don't care what it looks like, so you sort of juggle both worlds, and we pay consultants generally to do a nicely rendered model if we have to have a TV exposure for the design, or certainly magazines and things like that. So this is an image that's been done for the Regional Rail project by the architect. And I've probably raced a bit, but this is the last slide. I think it's a good one though. The story behind it is very interesting. You saw all those models that we had for Regional Rail. There was a guy on site took it home and had it on his laptop and was mucking around, and his son or daughter got on there and thought it was a computer game, so sort of had a bit of a look around and that sort of thing. And anyway, his 7-year-old child went to bed, or rather didn't go to bed, went into his room and did a drawing, stayed up all night apparently, thinking about it. and drew what his dad was looking at on the computer. And this is supposed to be a tower crane, and you know the way he interpreted it was really not too far from what it was. He's put some machines and stuff in there. But yeah, I mean, it's a great story because he engaged with his 7-year-old son with the work that he was doing. So that's a big high level story for BIM, is that it really helps everybody engage with each other and understand things much better. So plenty of time for questions and discussion.
Did you find initially that it was difficult managing what you produce modelling wise and like your information input into what practically goes on site, like in terms of contractors understanding, like taking off from the model, taking off what they actually had to physically do on site? Did you find there was any
I mean, for me, I understand the process. I've seen many things get materialised that were a model, that you know, modelling things and then seeing them built. But I get your question. The guys on site haven't come from that background, so you've got to work with them. You've got to get them to do the work. So we actually just print a lot of images, you know. So where they might have they would have previously got a stack of drawings and a construction program. They'll still get that, but we'll save out 200-300 images, viewpoints in the model, and just print them, you know. Because on site, you know, the game is to get the job built safely and as quickly as possible. So if someone's asking you for some information, as a project engineer, you give it to them if you can. And if they're saying, if the guys in the big, you know, the work crews are saying they want to see a folder full of printed images, well, that's what you give them. Because it helps them do their job. We got some really good situations where some of the leading guys, younger guys probably in the field, actually had a laptop. I had a photo last year, I think, where there was a laptop sitting on a drawing table, and they had the model. The drawings were actually screwed up in the corner, and they had this laptop with the model there. Because it was a simple task, they were just fitting out cable ladder, which was just like putting a Meccano set together where they had to find out what was the name of the next one to bolt it on. So we had it set up so they could just hover their mouse over the next piece, find out the name of it, go over to the pile of cable ladder, pick up the one with that tag, come back and bolt it up. And it's that sort of procedure. That's like a human job, you know, dictated by a computer, if you like, guided by a computer, but it's guided accurately. So if we can procedurize that sort of thing, we're really going to see some efficiency increase with this thing we call project engineering.
In terms of professional development, I mean, I know that the younger generation are getting right into all this computerised stuff, but the guys on site, does Thiess provide some kind of training when they're implementing a model? Is there some kind of briefing beforehand and equipment supplied, for example, to train these people who've never been exposed to working from a model?
Yeah, certainly on the big projects where we have, you'll find the model-based construction workflows are most intense in areas where there's high risk and where all the enablers are there, because we're still building jobs where we don't have that workflow because we literally don't have the information. But on projects where it is, you're absolutely right. We are a little stretched in terms of having the capability to have a robust sort of approach to that. Certainly, in my 3 years on Vic Diesel up to the end of 2011, I had lots of slides and help files that I could just, if somebody wanted to use the models, I had a package that I could give them. But I didn't have enough time to be able to run full training sessions. The beauty of it is, as you say, especially with the young guys, they actually don't need a lot of training. If you give them that basic startup guide and access to the information, access to the software, they're pretty much away with the basic navigation and all that sort of thing. So, and yeah, you know, the younger generations are quite inquisitive, we find. So, so they're okay. But we do certainly try to help people that the older generations that are wanting to get into it. And that's exactly part of the big challenge at the moment. When you're working with physical risk, the human nature is to do what you've always known, do what you've always done. But we need to change, so we're all trying to start to work together to get it right. And yeah, it'd be great if we just had infinite resource to put really good procedures and all that sort of thing in place. But I try to look at it as a triangulation. I say to people, don't rely on it entirely. You know, you still got to get your drawings, you still got to check your drawings, because they're still the contractual documentation. But if you can use this for information and do your job better because of it, well, you know, it's time well spent. So I remember when I went to uni in the late 90s, it was brand new then, and we basically, in mechanical engineering, we'd get a design project in third year. I remember we designed a cattle stun gun, and we designed an elevating work platform with Redmond Gary here on the coast actually. They made cherry pickers, and they were getting some free R&D by saying to UQ, see if you can put an extra section on the boom, right? Do all the calculations and everything. So we could do that, but the tools on the computer were there, but the professor, he actually didn't know, because he hadn't had the time to learn how to use it. So all he could say to us was just, look, there's the computer, there's the software, here's your project, good luck. You know? So I think people learn like that, you know? And there's no other way to do it, because everybody comes from where they come from. So you've got to work together, and you need people to sort of lead the way. So yeah, I heard the other day that an app, we got guys, actually got some guys in our company who run app, they build apps on the weekend and sell them, you know, like with their own companies. And you can't get around that, because they're the guys you need. Admittedly, you could suggest there's some sort of conflict of interest, but you can't, because you need them. So anyway, this guy I'm thinking of, he said to me, look, if I have to write a help file for my app, he said, my app's rubbish. Yep, he reckons any app, if you need a help file for it, then you didn't write it well enough. Which is interesting. I think that's the extreme, because you have some pretty complicated apps out there now, and I know I don't like having to go back to the book of rules, but I do. I happen to think that if Captain Cook didn't need any maps, then we should be able to just forge our way, but I understand everybody's not like that. So yeah, you have your help files and your different extremes. Yeah.
It's being used during the data stages of a project, or
say that again, sorry?
it's being used during the data stages of a project.
You can use it at every stage of the project. When he says addenda stage, is that tender, right? Yeah. Again, like if the facilitating conditions are there, which is the architect and the designer using BIM, and we'll be straight in there to use it, but we're still bidding jobs where either the client's not pushing for it, or the architect or the designer aren't up to speed yet. There's still some out there. So yeah, you think of it, there's an S-curve, which is the diffusion of any new innovation, and we're pretty close to the bottom. Like, it's starting to ramp up, but we're still pretty close to the bottom of it.
Have you found it's affected the time in the planning and design phase? Because obviously you're getting much more efficient projects in construction phase, but how have you found that it's affected the design and planning and like level of like amount of work that goes in prior? Is that like almost counterbalancing the time you save on site?
Certainly, and that's the argument you always put up. If somebody asks for a return on investment, I don't even talk about a monetary investment, I just talk about time. It's like you put the time in now, with that one curve, it was a little bit of time spent at the start of the project just facilitates a much more efficient project. And the best example I have is the one package of work we actually did in a completely model-based delivery at Big D Cell, was the one with the penetrations there. And because we got it right in the computer and we were happy with it being exactly right and communicated it well to the guys in the field, we virtually had zero rework in that package, which is huge, because typically rework in construction is about 30%, and on a bad project, it'll be up to 50%. So you think that's doing things twice. That's doing 50% of the things you got to do. You're doing them twice on a bad project. So what BIM can do is really reduce that and save you time. So tender planning, I say feasibility as early as possible. There's things you can do. You can optimise alignments these days for civil jobs that you can do. Put simulations together to optimise, the height of the floor height of your building. You can include parameters from standards in a software package and make things more simple for engineers to not even have to consider that parameter, which is a standard parameter all the time, so that he just has to play with the parameters that he's looking at. Number of columns, all sorts of things. My experience was actually with parametric modelling. Once I left uni, I went to London for 3 years and worked for Arup, which is a large design consultant, and I was building large steel roofs parametrically so that they could come back and change things later and have everything update. We did that a couple of times where there was a massive roof structure made out of steel. The engineers would test it and say, no, we need a thicker, wall thickness on the members. So we'd change it. It would change it once, it'd change everywhere, and then issue that volume of steel back to the steel fabricators who'd update their price. And that was 10 years ago. The UK and the US are ahead of us in a lot of respects. So yeah, it's been a 10-year period getting to where we are, and the wheels are really starting to move now, which is good.
Going back to the examples, not that we looked at the videos, but I think probably everybody's seen at least one of those ones of them constructing something in 10 days. There are a whole bunch of things about that though, aren't they? Very repetitive design.
Do you want to see if we can get them up?
If you like, has everybody seen one of those? They're the sort of thing that's been circulated quite a lot. But there are a few things to note. I mean, I know the first of those, the Chinese one, is a perfectly flat site. There's nothing around it. They can get any number of cranes and trucks and whatever in. I suspect it's the 6-day one.
Oh yeah, it's that one down the bottom there, wouldn't it be?
I mean, it's just the perfect. No, that was the one, the top one, the 6-day.
Oh, was it?
Yeah. It's everything. But of course, there must be some huge manufacturing facility somewhere where they're building.
Hey, it's Doug Coy for So What Do You Think? Man, sometimes you see some things that absolutely boggle your mind. I mean, you just go, how did they do that? Now, let me set it up by this. Over my shoulder here, we'll try to get a closer shot. You can just kind of see the BC Place. Now, I'm in Vancouver, British Columbia. We have this place called BC Place. And what they decided to do is put a new roof on it. And it's going to be one of these that, kind of opens and closes. Now, the only thing is, it won't open or close in the rain. But, who needs that, right? It's taken them like 2 years to put a roof on. So this guy sends me an email, right? He says, you got to take a look at this. The Chinese built a 15-story hotel. That's right, 15 stories. You said, well, a lot of people build a 15-story hotel in less than a week. They put the whole thing up, the foundation, all the floors, and they even say that it can withstand a 9.0 earthquake. Nobody got hurt. They worked 24 hours a day and put it up in under a week. I think it was just 6 days. So take a look at this. We have some time-lapse photography, and you won't believe it. I mean, take a look at this. And then here's the deal. I'll be right back. But take a look at this. You'll enjoy it. So is that not the most unbelievable thing you've ever seen? 15-story hotel built in China, 6 days. We have some guys just happen to be working on a roof over here, and you know, it's a simple thing. They're just putting on a small little roof. We'll get a picture of that as we go out. I bet you it's going to take them at least 2 days to finish that project, maybe 3. Hey guys, move to China. You can put up a hotel 15 stories in 6 days, no problemo. That's not Chinese, but it's amazing. This is Doug Coy. So what do you think?
Yeah, so my point about the nice flat site, the number of cranes around the site, all able to work. But there had to be a huge manufacturing facility somewhere. Whilst the actual putting up of the thing may have taken 6 days, there would been months of prefabrication.
Yep.
Months and months. And it's a very repetitive building. It's a pretty dull building, really. So there's, yes, it's doable, but it's a kind of false picture, isn't it, in a lot of ways. That's why it was making me wondered, I mean, does that sort of approach, you know, you talked about Lang O'Rourke and Ray O'Rourke's vision of building as being manufacturing, and certainly I know Lang O'Rourke in the UK particularly have moved towards, wherever possible, sort of modularisation and so on. But how does that affect you guys, given that you're doing engineering sort of work, which is it really, how applicable is that to you?
Well, it's quite applicable right now because one of the biggest challenges we have is with industrial relations, to be honest. It's actually getting the people to do the work on site. You know, there's a lot of things happening in the big wide world, I think, and we need to innovate to get better. As long as we innovate with everybody in mind, it's when people are working on a project with only their own faction of it in mind, that's when the rot sets in. So you can isolate, as I say, the industrial relations side of it, you can look at the government, you can look at architects, engineers, but at the end of the day, we as the contractor are the ones that turn up, take the bulk of the risk, and then either try and farm it out to subbies as best we can, or consultants, or take it on ourselves. And we've proven with the last couple of big jobs that we've, you know, there's been too many variables to manage, if you like. So in that sense, you think, all right, well, what can we do in order to make it easier for the other factions in the value chain? And modular prefabrication is a big sort of suggestion for the Australian industry, if you like, because we have to have agreements with the unions, with the workers' unions, and if we go and take packages of work off-site into the factory, you'll get an argument. You know what I mean? Because there's less work to do on-site. That's the work that those people are living on.
I was thinking of it more in terms of the kind of physical projects that you work on. I mean, okay, if it's a pipeline or something, well, that's understandable. It's going to be modular because you'll have bits of pipe get delivered that you basically weld together. But how do you modularise something like the D-cell plant?
Well, we tried. We don't. This is a hard luck story. We don't often get the opportunity because when you bid a job, you do an intensive period of tender, where there's you have a design. It's never the final design, but you bid on it as best you can. And then when the job's awarded, you have to go helter-skelter to get going. So you don't get any opportunity to modularise. We actually tried with some of the steel modules in Big D-cell to do that, but we got quoted a 6-week turnaround from our designer. So they said, that's too long, you know, we're not going to do it. Even though we'd done all the numbers, there was only a couple of small design changes. We pushed on our designer and said, you just got to make these design changes. Admittedly, we didn't have anybody who was going to push them hard enough to get them done. But that's what these tools bring to us, where you can prove to someone ahead of time that that's something you should be doing, is modularising your delivery strategy. And it's a people game at the end of the day, and people have their patch. So we're the industry's mediator. We're the ones who turn up and say, we're going to manage everybody and get this job done and make money out of it. Well, The last couple of jobs were too big for us to be able to do that and make money, just because of all the variables. But you'll find that the government won't actually give out those huge jobs anymore because they know that that's not going to work. So you get smaller projects, and as you come right down to the $100 million jobs, which we don't often get down to, we tend to stick up a bit higher than that. But those jobs, there's contractors out there, private contractors, that make really good money because they do the same thing over and over again, and they don't go any higher. They'll stick to their $100 million and even down to $10 million road jobs. And they do what a contractor does, which is coordinate people to do the work. So yeah, we really see ourselves as the industry's mediator, in which case we can't collaborate too much. That's not the view of a number of older generation people within the company, but the reality is, once we've won a job, the game is to get it done as quickly and as safely as possible, and the only way you do that, the best mechanism to do that is to collaborate. And the BIM stuff is one of the best ways we can collaborate ahead of time.
How are you finding the level of design that you're, or modelling that you're getting from your actual consultants in terms of experience and quality?
Yeah, it's pretty good. We're getting better. We actually got a model at expression of interest stage for a project in Melbourne last year, which was the first time we'd had that. They were a bit precious about issuing it at times, because if we could get them to issue it, we'd have quantities and whatnot well ahead of time. Whereas typically with the way that they get engaged, you often wouldn't get that until bid phase, when the client issues it to you, because the client's engaged someone to do a feasibility or reference design, and then that'll come back to the client and then come to us. So we're always hungry for information whenever we can get it. There's a lot of GIS information out there now, so a lot of stuff we can just log onto GIS and point it to a URL, and it'll pull the relevant information in. And that's when you really see decisions better decisions getting made ahead of time. So yeah, we're always information hungry because we want to share it with everybody to get better decisions to be made.
Any last questions? Right. We'd like to call it a day with a couple of hundred grams. Well, thanks, Andrew. Thank you very much. It's always good to hear what's really happening out there. But actually, it seems to me that you talk